circumscribed mean?
It's not a circle inside.
What? Circumscribed means what?
Circle, right?
No. What's in?
Wrong. You just said that answer and it's wrong.
Circum. The prefix circum means around.
Oh, I feel like I was right.
Okay. So. All right. Circumscribed would be that circle. Guys, we've talked about circumscribed on at least 3 or 4 different occasions, okay, throughout the year, okay? So circumscribed is that circle, okay? So the idea here is they say, going through this, they say that the octagon has a perimeter of 288, and it's going to be painted orange. The interior area is going to be painted orange. The remaining area of the figure is going to be painted blue. So that remaining area that they're referring to, let's see if I can get my... All right, so the remaining area that's supposed to be blue are these little chunks. Okay? There should be 8 of them, right? We want to know what is that total area. Okay? So how can I find those blue areas? What... Good. So we're going to find the area of the circle.
Did I say that wrong?
You said it right.
Okay.
Area of the circle.
A equals pi r squared.
Yeah. Minus the area of, in this case, it's an octagon, right?
Yeah, so it would be A equals 1/2 times AP.
Okay, good. So this is kind of in generic form would be area of circle minus area of octagon. In formula form, it'd be pi r squared, which is the area of a circle, minus 1/2 AP, which is the area of an octagon. Okay, that is not a standard formula because we just don't deal with this blue region very often. But finding these irregular shapes, blue regions would be maybe referred to as irregular. They're not normal, and we don't have really defined formulas for them. But we can do some operations with specific formulas, more common formulas, to develop those areas. Okay. So, have you, in your lifetime, found the area of a circle before? Yes. In the last 3 days, have we dealt with finding the areas of regular polygons? Okay. So.
Wait, can I have a question?
Yeah.
How do you spell inscribe?
How do you spell it? Okay. That's an I-N. So. That's different, okay, because we say that the octagon is inscribed in the circle, right? The circle is circumscribed about the octagon. Okay, so inscribed and circumscribed, we have to understand what objects we're talking about. All right, so if I look at this, I'm going to actually find the octagon area first.
That's easy.
Okay. Area of octagon, 1/2 AP. Do we know the perimeter in this question?
Not yet. Well, I don't know. Yeah, it's 288.
288. Okay. So multiply 1/2 times A times 288, and that should give us our octagon's area. Now, we don't know what A is. A, remember, is that apothem. Okay. The only number they give us throughout this question is that the perimeter is 288. So if the perimeter is 288, what would
36.
that distance be? It would be 36. How'd you get 36?
Divided it by 8.
Okay, you took 288 divided by 8 will give me that distance there to be 36. Now, am I really interested in 36? I'm interested in that portion of it. So I'm interested in that being 18. Okay. Now, I also need this angle here. And that angle, if you remember, we talked about as always being 360 divided by 2n. In this case, it'd be 360. 2n would be 16 in this case, n being the number of sides of the polygon. 22.5. So that angle is 22.5 degrees. Okay. Now, go ahead.
Why did you divide by 16? I thought you divided by 8.
We divide by 8 to get that blue angle. but I'm only interested in half that blue angle. So now I divide it by 2, and that will give me that 360 divided by 8, and then that quotient divided by 2 is same thing as 360 divided by 16. Okay, so now I got to find the apothem. So 18 is the opposite side, right? And A is the adjacent side, correct? Which trig ratio uses opposite and adjacent? Tangent. So I'm going to do tangent of 22.5 is equal to opposite over adjacent. So then it gives me the adjacent side to be 18 divided by tangent of 22.5. Is that okay? I did. Flip the A and flip the tangent 22.5. C S O H C A H T O A. So now that's the apothem, so that's the number that goes here, right? Okay. Now you could, and some people do this. Maybe I write it. So it was 18 divided by tangent of 22.5. So 43.455. So that's my apothem, right? Does that make sense? Okay. Right. And the idea is I told you to, I think, hundredths place, right? So my final answer I want to be to that place value. So if I'm going to use this number, I probably don't want to use that portion because rounding that to the hundredths place is going to drastically impact my final answer's rounding place of the hundredths place. So if I'm going to use this in place of that number, I probably want to write out that much of it. If not, maybe that much of it. Okay. Yes. Okay. And some of you do that, and that's fine. You can put the 43 point, like whatever that number was right here, multiply by half, multiply by 288. I prefer to do it this way. Basically, that 2 and that 18 are going to cancel, leave me a 9, right? Okay. Not cross multiply, because cross multiply is for proportion. This is just multiplication, so multiply straight across the top. So 288 times 9 is 2592. 2592. And then that was a 1, so the only thing on the bottom is 1 times tangent 22.5 times 1. So I'm left with just tangent of 22.5. Okay? This is the exact area of your octagon. Okay, now let's compare that to let's compare that to if I write 2592 divided by tangent of 22.5, it's that area there, right? We don't have that yet. We don't have the circle yet. But if I used rounded apothems, I'd have 0.5. Let's say I round it to 43.45. Maybe I rounded 3 decimal places as my apothem, and then times my perimeter of 288. Okay. Would you agree that those two numbers are pretty close to one another?
Yeah, once you get over.
But look, that one to the hundredths place is a 4, right? That one to the hundredths place is a 6. So even though I rounded this apothem to the thousandths place,
What if you round it back more?
okay, if I round it back more, so it's going to change. It's going to make 455. Make it like that. Okay. So now you see that doing that 43.4558. Okay. Yeah, it's still provided an issue there. It didn't round well enough. Okay, so maybe we make it 4, and now you're starting to see that the more of those decimals, the more accurate then we are. Does that kind of make sense? Okay. So in avoiding that, this is the practice. This is what we want to do. Write it this way because that doesn't make you round anything. So that's what's going to go right here. That's the area of your octagon. So we're going to write 2592 divided by then tangent of 22.5. Now we got to go and find the area of our circle. The area of our circle is pi r squared, right? Okay, pi is a,
3.14.
yep, and we're just going to leave it as pi because 3.14 is rounded, right? Okay, so now I got to find r. Come over here. This would be r, correct?
You got to figure out why. No, because it's not a 30. I don't know.
Well, if that's r, let's look at this part of the triangle.
R right with you.
No, because you're thinking 30, 60, 90s. This is the hypotenuse, right?
Oh,
Is this the opposite side?
Pythagorean theorem.
No. We use this thing. We use SOHCAHTOA, and we use that one because that's the opposite, and that's the hypotenuse. So I would say sine of 22.5 is equal to opposite over hypotenuse. Then the hypotenuse will be 18 divided by sine of 22.5. Does everybody see that radius of the the radius of the octagon, keep messing up. The radius of that octagon is the same as the radius of the circle? We recognize that? Okay. These points here, these points are being shared by those shapes, correct? Okay, the center are both being shared as centers for the circle and the octagon, and that point there is a vertex of the octagon and is also a point on the circle. Okay, does that make sense to everybody? All right. So then, plugging that r in up here, we would have 18 divided by sine of 22.5, but we're going to square that because it's r squared, right? Rewriting that, we get pi. 18 squared is 324. So squaring a fraction, you square the top and you square the bottom. And this is how we square sine and cosine and even tangent. We just imply that we're squaring it. Does that make sense? And now this pi is also a fraction, pi over 1. So can I put that, so this is a fraction here, times pi over 1, which is a fraction. So when I multiply fractions, it's numerator times numerator, denominator times denominator, right? So what's 324 times pi? We just write it as 324 pi. Sine times 1 is just the same. So that right there is your area of your circle. So that's what I'm going to put right here. 324 pi over...
Now can we change pi to 3.14?
Nope. We're never going to change it to 3.14. Because that is another situation where we get rounding error that we don't want to have. Okay? 3.14 was used in, 5th grade, 6th grade, 7th grade, 22 sevenths. The fraction was used a lot. But those are approximations for pi, which means that if we use them in our area formulas, then our area is an approximation for what the actual area is. Does that make sense? Now, to a certain degree, maybe approximations are fine. Maybe, depending on the situation, the content of the question, that question with the soccer ball, maybe I don't need to be exact. Maybe out to 3 or 4 decimal places is enough, okay? Because thinking about taking like pieces of leather and cutting out hexagons and pentagons, I probably don't need to be at a very, very, very scientific, accurate, precise value. Does that make sense? I could be off a little bit and still be okay. Still make soccer ball. But if we're talking about doing calculations for like NASA or something like that, or the military, I probably don't want to round things to like whole numbers or tenths place and stuff like that. Okay. When we try to find the solution then here as a decimal, because that is what I asked you to do, we're going to show the reason I write these as exact values because then I can go to my calculator. 324 pi divided by sine of 22.5 should be able to square that. Okay, I just typed in the words pi. Oh, on that, yeah. Okay, so then 2592 divided by tangent of 22.5 Hit enter, and there is the area of those blue regions. Does that make sense? Okay. Now, I'm assuming that maybe some of us didn't do that. Some of us probably said, right here, when I found R, maybe you took 18 divided by sine of 22.5 and said, okay, 47.036 is my R value. And then you squared that, and then you multiplied that by pi. Would you guys agree that some of us maybe did that? Okay, so there's the area of my circle. And then, like I said earlier, when you did, I might have done 1/2 my apothem, which, let me check the apothem real quick, was 18 divided by 10, just a second, 22.5. All right, so maybe you said your apothem when you calculated it, and I've deleted it, but it was, the apothem was 18 divided by tangent 22.5. You might have gone to the side and said, okay, that number, 18 divided by tangent of 22.5, you got that right there. So then you took 1/2 times your apothem of, maybe you took it to 43.4558, and then times 288. Okay. Now I did some rounding here. I cut that amount off when I plugged into the 1/2 AP formula, correct?
Mm-hmm.
But how many times does that amount get amplified when I multiply by 0.5 and 288? It gets amplified 144 times, doesn't it?
Yeah.
Okay. And you can see then the discrepancy of the solutions here. If I were to take that number, which is a rounded area from a circle, now it's a decent approximation, and subtract from it that one, which again is the wrong button. So decent approximation for circle, decent approximation for octagon. There's that answer. Let's go back and compare that to the exact answer. And the exact answer was this one right here. And you see that if they ask me in this one to round to the 100th place, I can do that and get 0.85. Be the solution that matches up to what we're looking for, right? But if I do that in the one that I've rounded, the 692 is the same. But if I round to the 100th place, it's now 0.78, right? And that's an issue, okay? Especially if, we're trying to match our answers to something that somebody's already predefined inside Math Excel, any other math platform that you enter your homework into, or maybe in, of course, exams, okay? So the benefit of being able to write our answers and do the work as an exact answer, get the exact solution, and then if needed as a decimal, then convert it, is so much better than hoping that a rounded intermediate value is far. Does that make sense? Because when I took that 43.4558, I initially thought that's gonna be fine. That's enough. But we see it when we amplify it by 144 times that impacts the final answer to that decimal place. So those are things we got to think about, and those are things that impact a lot of stuff that we do. And if you are in chemistry, okay, sig figs, right? Sig figs are the purpose of sig figs is to address this issue, okay? Because we don't want Cole to round one way. Maybe Cole rounds out to 4 decimal places, but Braden rounds out to 2 decimal places. They get 2 different answers to the 10th place, but they both do the same work, right? Who is right? Who do we say is right? Well, sig figs gets us, it's a structure that gets us all on the same page, and our rounding is all done the same way. Does that make sense? So then if they both did the algebra correctly, they both get the same results. Okay? So if you're not in chemistry and you're going to be there next year, hopefully maybe when you see significant figures, this kind of it hits home on why one of the purposes of us using them. What if I wanted to find, so this is let's just go back up to the 692 number. That's the exact area. What if I just wanted to find one of these blue regions? What would I do with that 692 number?
Divided by 7 for 8.
Divide that by 8. Okay, they're all the same, right? Okay, and that is actually a process, guys, that people are interested in because let me just clean some things up here. A lot of times a common question is to,
Wait, so when you,
oh, go ahead.
when you divide it 360 by 8, you get that figure right there. And then you divide it by 2, you get the smaller one. Or you get half, I guess.
Yeah. Sometimes a common question, guys, is can you find the area of that thing right there?
Yeah, we just do what we just did.
We do what we just did, and then we take that quantity and divide it by 8, right? Okay. That little segment right there, if you think about it, it's, if it's a piece of pizza or a piece of pie, that's the crust, right? We call that a segment of a circle. Okay. Ultimately defined by the area enclosed by the circumference and the chord. But we have the ability to find that area, right? There's not a really nice convenient formula. Okay, there's not a shortcut, quick technique. There are a couple other techniques, but they all kind of stem from what we just did. We could ask those questions. All right. Now, thinking about those questions, did I ever do an example with you like that? No. Okay. But did we do an area question for pentagons, hexagons, octagons, decagons in class, right? And you've done circle areas before, okay? So then it takes a little bit of creative thought to realize what am I doing then in this overall problem? How do I put those together to get what they're
That's
asking for?
confusing with the solar.
And that's using, and that's important. We got to be able to use it. You're going to be asked to use that next week. Okay, SOHCAHTOA is on that test. We also, I can't do this problem if there's debate on what circumscribe means, right? Some people would have done this question, but maybe done it with, let's see here. Let's go back to standard view. Some of us maybe did that question with this picture. This is so the circle's on the inside, right? Well, the circle's on the inside. That's an inscribed circle, and now this is how we address question number 2. The circle, so the green circle is inscribed inside the red decagon. Okay, so this question, I believe they tell you that the radius is 20.
I didn't get to this question. I was stuck on that.
Okay. So reading this one, it says a circle is inscribed inside a decagon. Okay. Decagon has a radius of 20. Circles to be painted green. The remaining areas to be painted red. Okay. So the red area that we're looking on, I'm just going to zoom in here.
How much does decagon have?
10. Deca means 10.
So that has 10?
Yep. Okay. So the red area, and I just colored it all black. Let's color it red. Is going to be that region plus that region plus that region. Does that make sense, everybody? So we're trying to find all of those added up, and there should be 10 of them. Okay. So working with kind of a formula here, which figure would be bigger, the decagon or the circle? Okay, the decagon. So we're going to go decagon minus circle, right? Talking about areas. And if we do that, we should be able to address those little individual areas. Okay. The rate. Okay, so that's what we got to pay attention to. If we're looking at the circle, is that 20? Is that 20 the radius of the circle? No. Okay. What segment is the radius of the circle? The apothem. So this is your apothem for the polygon. Apothem for the polygon is equal to the radius of the circle in this problem. Okay. So that's a key fact that we need to realize. No. Are you saying can the radius of the circle be the apothem? Is that what you mean?
Could the radius of the circle be an apothem of the hexagon?
Yes. And that yes. So area of a decagon is 1/2 AP, right? Okay. So 1/2. Now we don't know our apothegm, and we don't know our perimeter. So those are both things that we have to find through the use of this 20. And this angle here, 360 divided by 2n. 360. 2n would be 20. So does that angle turn to be 18 degrees? Well, what's 36? Because they both have a factor of 10 in them, right?
Oh, yeah, it's 18.
Okay. So now, if I want to find A,
Would you have to divide by 2?
the 360 divided by 20 is incorporating that too.
Oh, 360 divided by 20 is 36.
360 divided by 2n is what we do. N is the number of sides, so it becomes 360 divided by 2 times 10. So if I want to take it 360 divided by 10, it would give me that angle. And I think that's what you keep asking about, is that angle there, right?
Yeah, it does get you 360.
And then you split that,
Okay, so
and
you
that
have
gets
to
you
divide by
the 18. So I do it all at once. So it gives me the 18 that I need for this angle. All right, so if that's 18, what side is 20 for this triangle in regards to that 18? It's the hypotenuse. What side is A? So it's adjacent. Okay. So which trig ratio uses adjacent and hypotenuse?
Adjacent
Cosine.
C.
So I say cosine of my angle is equal to the adjacent side divided by the hypotenuse. Multiply both sides by 20. And there's my apothegm. 20 cosine. Yep. I mean, I don't flip them because whenever I have fractions, I multiply by that denominator to get rid of the fraction. So multiply both sides by 20, and it gives me that. Okay. So now I gotta find my perimeter, and I don't know my perimeter, but would you guys agree that your perimeter is, to find a starting point for it, we could use that distance there?
Yeah, but we don't know it. Do we?
Okay, we don't know it. Let's just call it something. Let's call it, you say x? That's fine. So x is opposite 18, isn't it?
Yeah.
So can I use opposite and hypotenuse to find x?
Wouldn't it be 18?
No. Can I say sine of 18 is equal to the opposite side?
Wait, how do you get sine?
Because this is opposite, and this is hypotenuse. And SOHCAHTOA, sine is the one that uses opposite and hypotenuse. Okay, so 20 sine 18 is equal to x, correct? All right. What do I need to do that x to get a side length of my decagon?
Multiply, wait, what do you mean? Times by 2?
Times it by 2, so that will give me one side length of my decagon. So keep that in mind. We multiply it by 2. If I multiply it by 2, that gives me a side. What do I need to do to that to multiply?
Multiply it by, what was it, 12? Or 10?
10. And multiply it by 10 to get my perimeter, right? So ultimately, I'll be taking this number, doubling it, and then multiplying it by 10. So I'm ultimately multiplying it by what?
12.
Nope. 20. Okay. So multiplying by 20 will turn that small value of x into my perimeter. So that turns into 400 sine of 18, and that is your perimeter.
400 sine of 18?
Yep. And that's the exact version of your decagon's area.
Wait, so your apothegm is 20 cosine 18?
Yep. Now all these numbers, I think I've got 1, 2, 3, 4, I got 5 numbers here. Okay? Underline those numbers. Those numbers are all rational. They all work well together, right? So what's 1/2 of 20? 10. What's 10 times 400 then? 4,000. So my area of my decagon becomes 4,000. So that took care of that, took care of that, took care of that. And the things that are left over are cosine 18, sine 18. And we imply the multiplication. We don't actually do it. We just write them right next to each other so that we know that is the operation occurring between those 3 numbers up there. Okay, because cosine 18, sine 18, irrational numbers, and they're not really nice at this moment. So that's the area of your decagon. Now we want to find the area of our circle. Okay, what's the formula for the area of a circle? Pi r squared. Okay, so just kind of chop this up here. Circle. Apologize, hold on. All right, circle is going to be pi r squared. Over here in your picture, what is it?
It'd be cosine 18 times pi.
Okay, so I don't care.
No,
It's a, right? Would you guys agree with that distance right there?
I just my answer.
Yeah.
It'd be pi cosine of 18 squared.
Close. You're missing the 20 here.
Oh, I was looking at the top part. Yeah, it'd be 20 cosine squared times pi.
Right, because that distance right there, which is your apothem, right, is also the radius of the inscribed circle. And that's what we said, as we wrote down at the beginning. The apothem is equal to the radius of the inscribed circle. So we have pi times r, but r is now 20 cosine
18.
of 18. And we square that, okay? Now, this is a number times a number squared, and it'd be something like this. It'd be, 2 maybe times 5 squared. What's 2 squared?
2 squared is 4.
4. What's 5 squared?
25.
25. What's 4 times 25? 100. So in that situation, you can square that term, and then multiply them together, right?
Yeah.
So same thing here. What's 20 squared?
400.
400. Now, we haven't seen this too much, but cosine squared is just going to look like this. Cosine 18, and then we square it. And we also got this pi here, right? You multiply that pi, you put it here.
I thought you put it underneath.
Not underneath, because it's over 1 right now, and these are all over 1. So they're numerators. You put that pi kind of anywhere, the common practice. The most time you're going to see people put it right behind that 400. It's just the way they don't have a set of directions to say why. But,
So that's your answer?
so that's the area of my circle. So I'm subtracting 400 pi cosine of 18
1,000.
squared. Again, did you do this for your homework? Probably not in this format, right? You probably found 20 cosine 18, hit enter on your calculator. That gave you your apothem as a decimal. You rounded it to something. Then you plug that into your formulas, right? By all means, that's fine. But I want to open your eyes to what we do in other math classes, okay? And start to realize, because I know some people in the past have sat through and said, this isn't going to help me in Algebra 2. It's not going to help me in trig. And then they get to Algebra 2 and they get to trig, and it blows their mind away that something I taught them in geometry, if they would have learned it, they would have made life so much easier as a junior or a senior, okay?
I got 38 when I subtracted them. I don't know if that's
Okay, that's in the ballpark of the right, like 38.93 or something like that.
604.
Okay.
Okay, so like, you subtract the 400 or 4,000 cosine to the 400 pi to get the area for like the rest of it.
For the final answer, I'm just gonna type this whole thing in,
Oh, okay.
because this was the red one was the individual area of the decagon, the black one is the individual area of the circle, and then that minus sign is that minus sign right there. So when we type these in, and this is again, a TIA 384 does a terrible job at this because of the way it's kind of programmed and display that's provided. I like Desmos because it's going to when I start typing, obviously uses that kind of that math, we call math print sometimes. It's going to put it kind of like how I have it written by hand. So minus 400 pi then, and then cosine 18. Square that. And there's that number right there. Is that what you came up with?
464. Mine rounded it.
So yours was, at that point, changed it? Okay. So if we're to the 10th place or whatever, 100th place would be fine.
Yeah.
But again, guys, if I said 20 cosine of 18, which is my apothem, okay, if I use that number right there and with pi times 19.021, and I square that, there's the area of my circle, which is that the same thing as 400 pi cosine of 18 squared? Pretty close, right? But look, I round this out to 3 decimal places. Yeah, and the first number right there after the decimal place is the only thing that's accurate. So rounding that to 3 places creates an error just in the area formed in a circle. It creates an error at the 100th place. So there's always a question, well, how far do I go out? I don't know. It depends on what your next operations to that rounded number are going to be and how many of those operations you're going to do. The general convention is round as late as possible. Well, late as possible is to learn how to write your answers as exact answers and then round that. Okay? And that's kind of what we're going to try to do. That's what a lot of, I know you're not 100% skilled at this, okay, and people struggle with this, and that's fine. You're going to. But Algebra 2 is going to get you to practice that. By the time you get to college algebra, you're going to have a really good skill at that, and you're going to be really proficient at that, okay? And we can use those things in algebra, or college algebra, trigonometry, calculus, and even your integrated 3s and 4s, and even statistics. A lot of fractions and weird operations occurring in statistics. The ability to do this is going to be very beneficial. All right, so we're not going to have time to get to the last question, so I'll put together a video of the last question. But this is where I want to eventually take this stuff. Okay. So we just found the area to be 38.931 square units. So let's just say that those units were meters. Okay, so that meters square unit. I'm eventually going to say, what if paint costs $43.28 per gallon? Okay. Somebody said, well, that's ridiculous. If you go look at paint's actually pretty expensive. And then I give you some facts, because every paint can has these facts on the back. It says, usually it's in terms of a full gallon, but it says a gallon, in this case 2/3 of a gallon, is going to cover 12 square feet. And I ask you, how much will the paint cost you if you buy that paint in Texas?
Doesn't make any sense.
Okay. What doesn't make sense? Why am I doing it in Texas?
Because everything's done in Texas.
No.
Everything's bigger in Texas.
No. It's going to cost me more in Texas than it will in Ohio. It costs me more in Texas than it will in California. Because the sales tax in Texas is different than
only
the sales tax in
0.7.
Ohio. Okay. So the sales tax in Texas, I just did a quick Google search of this earlier, it's 8.25%. At least that's what Google's reporting. Okay. So that's what we're going to be doing. Okay. And let's see here. Oh, I don't want to do that. So if that's what we're going to do, let's see if we can go through this and at least set it up. Okay, because I think we got some time to do this. Right now, I have 38.931 meters squared, right?
Wait, can we round that up to 40 or no?
No. Because I want the most precise penny possible. Okay? So that's meter squared. What does meter squared means? Meters times meters, doesn't it?
I don't know.
It does.
Okay.
So I want to write it that way. So that's what I start with. And if we look at the last question here, it says, how much will it cost? So cost is in regards to, in this case, going to be in dollars, right? All right. Do you guys remember, if you're in chemistry, you've done this. You've changed moles to grams and stuff like that, right? Grams to moles, Avogadro's number, those things kind of hit home. Okay. We want to use called dimensional analysis, unit conversions, that kind of stuff. We want to get these meters to disappear. We want dollars to show up. The only way I know how to get meters to disappear is to relate it to maybe something a little bit smaller. Would meters and centimeters relate to one another? Okay. How many centimeters are there in a meter?
Like 100?
100. Centi means 100. So that is going to get that M and that M to cancel out because the one's on top and one's on the bottom, right? How do I get the other M to cancel out? Do the same thing. 100 centimeters to 1 meter. Now that meter and that meter cancel out. Does that make sense to everybody?
Wait, can you wait a second while I write down the paint thing?
Well, we're going to run out of time if I do that.
Alright, you're good. I'll write
So, supposed to be,
well, this feeling
I'll
there.
publish this, yeah.
Alright, sweet.
All right, so then I want centimeters to cancel out. Now, this might not be something you guys know right now, but inches and centimeters are relatable. 1 inch,
It has 10 centimeters.
2.54 centimeters.
What is the equals? Wait,
So I'm going to do that twice because I need both sets of centimeters to cancel out.
how do you think it out?
Because I want to go from
Can you
meters
go
squared.
from meters to inches or no?
I mean, there is a conversion for that, but I don't know. I don't have it memorized, and you're probably not going to either.
No, probably not.
So now I want inches to go to feet. And why did I want to go to feet?
Because it's easier than square feet.
Well, yeah, because square feet is going to be a necessity, right? I need those units, 12 inches for every 1 foot. I need those feet squared because now this conversion, this says 2/3 gallons per square feet. Okay? So I can now take 2/3, put a G there for gallons
Wait,
for every 12 square feet. We can cancel those. And now what's nice about that is that gallons, every 1 gallon costs $43.28, right? And now the G's cancel out, and the only units I'd be left with are dollars. So I multiply all those numerators, multiply all those denominators, divide them out, and now I have how much money it cost me pre-tax.
I have a question.
So then what do I do with that number?
I have a question. Multiply by 8.25.
8.25. Multiply by 8.25%, and then add that back to the number that I got up there, right? An easier thing to do is to, when you pay sales tax, you're paying 100% of the item
Plus more.
plus more, right?
They like tear.
So I'm paying 8.25% more, correct?
Yeah.
So why don't I take 100 plus 8.25% and actually use that as what I multiply by? So take whatever that number, whatever that multiplies out to be, and multiply it by 1.0825, and that will tell me how much money then I need to go to the paint store to buy this paint. Provided the paint store will give me paint kind of per volume, okay? They'll measure out that volume that I need for me, instead of having to buy any full cans or something like that. Okay. This is where we're going. The next 30 days, guys, this is what we're going to focus on. Because I am interested in you being able to do area and volume. But I'm also a lot more interested in you being able to do something like this. Because at some point, most of you are going to probably own homes, right? You're probably going to carpet that home, floor that home, paint that home, wallpaper that home, plant grass in that home, mulch your flower beds. And you're going to use conversions to give yourself an idea of how much it's going to cost you, how much you need to go to the store and get, or call and have shipped to you. Does that kind of make sense? Okay? So I want you to have the ability to do this and not have to rely on somebody else to do it for you. Okay? I'm going to find some articles that shows you that when people can't convert like this, and we have historical moments showing this, when people mess up conversions, people die, okay? Planes crash, things like that. Bridges fall down.
Would you
Okay?
round it? I multiplied the whole time.
So the hope is that we can all eventually be able to do this.
Would you round it 2 halves since it's 1?
That's fine.
We're gonna homework.
There is no homework this